Hello, dear students. I am Lalitkumar P. Bhaiya, Associate Professor in Electronics and Telecommunication Department, Bharati College of Engineering and Technology, Durg. Today, we will discuss about the infinite impulse response filter called as the IIR filter, which is unit number 3 of the subject digital signal processing of 6th semester electrical engineering. Let us see what is this IIR filters. There are two types of basically filters. These are IIR filter and FIR filter, out of which we will see in a broad way IIR filter. Here you can see IIR digital filter design. Convert the digital filter specifications into an analog prototype, low pass filter specification. Then determine the analog low pass filter transfer function, this one, and then transform this analog transfer function HA of S by replacing the complex variable to the digital transfer function G of Z, or you can denote by anything. H of Z you can denote also, so there is no problem. So what we do with the standard approach, we have to convert this analog filter into digital filter, H of S into H of Z or G of Z. So we have to follow this standard approach. The approach has been widely used for the following reasons. Analog approximation techniques are highly advanced. They usually yield closed form solutions, and extensive tables are available for conversion of analog filter to digital filter with respect to design. Very often applications require digital simulation of analog systems. This is the transfer function which we can represent H of S, that is analog, as well as the digital function in terms of this Z transform, G of Z or H of Z. So this is analog and this is digital. So we have to convert this analog filter into digital filter as the IIR digital filter design. Here the mapping is important. Mapping function should be such that imaginary, that is J omega axis in the S plane must be mapped onto the unit circle of the Z plane. Here the S plane is mapped into the Z plane because we are converting the analog into digital filters. That is why mapping is also important. Let us see this mapping. I will tell you here with respect to the diagram. This you can see with the help of the bilinear transformation, we can map this analog domain, that is S domain, into this digital domain. Here this circle indicates the unit circle in Z transform, while this is the left hand side of the S plane, which shows the stable domain, and inside of the unit circle shows the stable domain. So this left side will map into the inside of the unit circle, that in Z transform. Similarly, these points are mapped with the help of the unit circle in Z plane. So this is called as mapping of S domain into Z domain, or in another way, broad way, you can say conversion of analog filter into digital filter. So this type of mapping is important. Let us go. This is the IIR digital filter. There are various methods for conversion of the IIR filter, analog filter into digital filter. One of them is the bilinear transformation. Another is the impulse invariance method. This in bilinear transformation, you can see this the digital domain, and this is available analog domain. Here if we observe this, if the digital domain becomes stable when available analog domain is stable. Real and rationals in Z transform, real and rationals in S transform. Here order n, here is also order n. Here low pass filter cutoff frequency is omega c. Here low pass filter cutoff frequency is omega c into t. This is the transformation with respect to the BLT, that is bilinear transformation technique. These are the functions which is shown here, and we can follow the particular procedure. This is the procedure, and this is the transformation function with respect to the bilinear. S is equal to omega c upon tan omega ct by 2 into 1 minus z inverse upon 1 plus z inverse is the formula for the bilinear transformation from analog to digital filter. This is the mapping from S plane to Z plane. This is shown here. This is, I have already told about the bilinear transformation mapping. This is the bilinear transformation area with respect to the axis. We can show here. This is mapping is highly non-linear. This is due to the frequencies. This is bilinear mapping graphical review. Here it is shown the warping effect. Warping effect is also important. Non-linear mapping introduces a distortion in the frequency axis, is called as the frequency warping. Sometimes it may be asked for the 2 mark, what is the frequency warping? So you can explain this frequency warping technique which is shown here from analog to digital with respect to the IIR filters in bilinear transformation. This is spectral. Here is no need to see this spectral transformation. Spectral transformation means we have to convert this z into e to the power j omega and see all the spectrums in the frequency domain. Low pass to low pass spectral transformation. This is low pass to low pass spectral transformation. Low pass to low pass spectral transformation. This is low pass to high pass spectral transformation. Similarly, all type of spectral transformation. This is called as frequency transformation. So this frequency transformation is important. In case of this, we have to learn this only the design procedure of the bilinear transformation, which we have already seen the formula. Similarly, we have to go for the other impulse invariance method and other methods, that is forward differentiation and backward differentiation method. Low pass to band pass spectrum, low pass to band, these are all spectrum. So this is all about the IIR filters. We will learn more later on. Thank you very much.